right, so Unit 8 is modeling and data analysis. You have on the front of your journal all your important dates. So the very first thing is the homework you're going to get today, and that's going to be due on Monday. Notice there's not as much in this unit. So you only have 2 Canvas quizzes on the homework side, on the high school side. And then there's only 1 college homework. Okay, so it's after you've learned everything, so it'll cover everything. So don't do the college homework until we've gone through everything in the packet. Okay, so we're going to start with modeling and data analysis, and a lot of this you did actually in Algebra 2, which I know some of us we learned remotely, so we need a better foundation. All right, so Unit 8, modeling and data analysis. We're going to be looking at regressions and variation. So that's going to be a big topic in this unit. So when you get a chance, make sure you read through this. Y'all have done regressions, and we will be doing regressions on the calculator. They will not require you to do the actual regression on the test because the test is a non-calculator test. So you won't have to worry about actually performing regression on the test. You will be given a regression, and you'll have to determine whether it's a good one or a bad one. Okay, so that will be something you'll have to do, which we'll talk about. Today we're going to focus on 8.1, which is just direct and inverse variation. So direct variation is a function of the form y equals k times x to the n. K is a constant, so that means it doesn't change. It's like a slope in front of a y equals mx, okay, without a plus b. So the k is kind of like a slope, it doesn't change, okay? K is a constant belonging to real numbers, and n is a positive number. Remember what happens if you have x to the negative something, that moves it to the denominator. So x has to stay up next to k in the numerator if this was a fraction, okay? All right, and this is known as direct variation. We say y is directly proportional to x. So if they give you 2 things and they say like volume is directly proportional to temperature, right? So the v would be the y. V equals, so whatever comes first. So y is directly proportional to x to the n. So that's going to be y equals k. That's your constant. It's never going to change. X to the n. Okay? And then the k is your constant of proportionality. It never changes. Your inverse variation is almost the same, except instead of multiplying k by x to the n, now we're going to divide k by x to the n power. And other than that, everything's the same. K is still a constant belonging to real numbers. N is still a positive integer. And this time we're known as inverse variation when that variable is on the bottom of the fraction in the denominator. And we say y is inversely proportional to x to the n. And again, k is still the constant of proportionality. Okay? So if I look at this has it's called joint variation. And so there's multiple things happening here. So I'm going to write down joint variation. In case you ever see that term again. We have t is equal to kr squared over s cubed. It says r and s are variables, and k is a constant, and this is a combined or joint variation. Okay? When it says to describe the variations that exist between t, r, and s, there's lots of different things we could say. We can say t varies directly with, what variable is it directly varying with? R or s? Directly. S is in the denominator. If we want directly, we want the one that's multiplied to k. So that would be R. So we could say t varies directly with, oops, I forgot the I. And it's actually with r squared, right? Because there's a square on that r. Okay? T varies inversely with what? S cubed. Now here's kind of a tricky one that we don't always think about that we could do. If I took this equation, t equals kr squared over s cubed, we could multiply both sides by s cubed So it would cancel out on the right-hand side, and I'd have s cubed times t equals kr squared. So now, once I've done that, if I look at this equation, and I want to compare s cubed to r squared, I could say s cubed varies with r squared. How does it vary? Look at r's relationship with k. Directly. It's multiplied to k. But wait, there's more. I could then come over here and divide both sides by t. So that I end up with s cubed equals k r squared over t. If I do that, and I look at this equation, s cubed varies with t. How does s cubed vary with t? Inversely. Very good. Inversely. All right. There are some variation functions that are widely used. One is Sir Isaac Newton's second law of motion that states acceleration of an object is produced by a net force as is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Okay? So here we have this notation. I have this F, and then it looks like a little like fishy shape, and an A. That little fishy shape stands for is directly proportional to. So the force is directly proportional to, and then the A, what do we think this A is standing for? What does it say we're directly proportional to? Acceleration, yeah. Okay. Then down here, I have the force equals ma. Okay, where m is going to be your mass, and then a is going to be your acceleration. So m is kind of like your, it's kind of like your k, right, in front of that a. And then down here we've solved it. We've divided both sides by a, and we have a, the acceleration, equals the force over mass. So remember, you can always, this is just showing you can always manipulate and divide, and you can solve for any variable. It's basically what this is showing you. Okay? All right, so let's look at this exercise 8.1.1, variation functions and applications. You might be able to fit this work on this paper if you like write all over the paper, but of course I like to make it nice and pretty, so I'm going to do it on my own paper. It says for problems 1 through 4, assume y varies directly with x, find the constant of proportionality, and a representative function for each problem. Okay, so number 1 says y equals 2.8 when x equals 2. So here's how we do this. We are saying y varies directly with x. So that is the formula. Let me come over here. This is exercise 8.1. Number 1, we're saying y varies directly with x. So y equals kx. Y is 2.8 when x is 2. How do I solve this to find the constant of proportionality? Yeah, divide k by the x value, which we know is 2. So divide both sides by 2. What's 2.8 divided by 2? It's what?
No idea.
2.8 divided in half. What's 28 divided in half?
1.4.
1.4. So that's my constant of proportionality is 1.4. That means the equation because it also says find the constant of proportionality. That's done. And find a representative function. My representative function is going to be y equals k 1.4 x. So those are my answers. That's my k value, 1.4, and y equals 1.4x. So for number 1, k equals 1.4, y equals 1.4x. All right, now we're going to do number 2. Y equals 1/2 when x equals 1/4. Okay, so number 2, y equals kx. Y equals 2 when x equals 1/4. Now, when you multiply something by 1/4, that can be rewritten as 2 equals k over 4. Do you agree? K times 1/4 is k divided by 4. That's going to help us be able to solve this a little bit easier, especially without a calculator. All right, so how do I get rid of that 4 then? Multiply both sides by 4. So what does k equal? K equals 8. So what is my equation? Y equals 8. Oops, not 8k, 8x. Okay? Are we paying attention?
Yes.
Okay. All right, so k was 8, which means my equation, my function, is y equals 8x. All right, number 3, y equals 0.6 when x equals 0.4. So number 3, y equals kx. Y equals 0.6 when x equals 0.4. How do I solve? Divide by 4, or 0.4. .6 divided by 0.4 is going to give you the same result as 6 divided by 4. What's that going to reduce to? 0.3 over 0.2, but we don't want to have the decimals if we can, when you simplify, you don't have decimals. So 0.3 over 0.2. Think about if you multiplied it by 10 over 10, that wouldn't change it. 3 over 2. That's your value for k. So then what's your equation? Y equals 3 over 2 x. Okay? All right. Oops, I didn't write it in my textbook. K is 3/2. So y is 3/2 x. All right, the last one on this section is number 4, and it says, for number 4, y equals 5 when x equals 0.5. So y equals 5 when x equals 0.5. I'm going to change that to 1/2, because then I know I can write that as 5 equals k over 2, right? When you multiply something by 1/2, you're really dividing it by 2. When you find 1/2 of something. All right, so how do I get rid of the 2 that's under the k? Multiply both sides by 2. Because most of us have a hard time dividing by 1/2 in our head, but we can all multiply 2 times 5 and get k equals 2 times 5? 10. So what's my equation?
Y equals 10x.
Y equals 10x. So I have k equals 10. So y equals 10x. x. Easy peasy. All right, number 5 wants me to graph those functions. So that's easy enough because basically they all have a b value of 0. They're all y equals mx plus b. They all have a b value of 0. So I just have to graph it. Now this one's a little harder because we need to know what is 1.4 as a rise over a run, because it's hard to rise 1.4 run 1, for me anyways, on a graph. But 1.4, if I wanted to change 1.4 to a fraction, that would be, let's see, that's 5/5, that's 2/5, so that would be 7/5. Every 0.2 is a fifth. So if I have a 0.4, that's 2/5. 0.2, 0.2, 0.4. And then a whole number, if I'm dealing with fifths, there's 5 of them. 5/5 gives me the 1. 2/5 gives me the 0.4. So that's a total of 7/5. So to graph number 1, I need to graph a slope of 7/5 that goes through a b value of 0 because there's nothing added on the end. So it's going to go through 0, and then it's going to go up 7 over 5. I don't have enough room to put another one, but I could also go down 7, back 5. Oops, I only went back 2. And so here is y equals 1.4x. The second one was 8x. So that's easy. A rise is 8 over 1, right? So rise 8, run 1. So from the origin, because it doesn't have anything added to the end, I'm going to rise 1, 2, 3, 4, 5, 6, 7, 8 over 1. Or I could go down 1, 2, 3, 4, 5, 6, 7, 8, back 1. And here is y equals 8x. The third one we looked at was 3/2 x, y equals 3/2 x. It's nice we left it as a fraction because that way it's easy to graph. Up 3 over 2. So from the origin, because nothing's added, 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. So it's close to the blue line, but not quite equal. It's a little bit steeper, which makes sense because 3 divided by 2 is 1.5, so it's a little bit bigger of a slope, right, than 1.4. So 1.5 and 1.4, those are real close together, so it makes sense that those slopes would be very close to each other. 3/2 x. And then last but not least, my fourth one, y equals 10x. So that's just go up 10 over 1, which is going to be real close to 8x, just a little steeper. Y equals 10x. Remember, the bigger your constant of proportion gets, the steeper your slope is, so the steeper your line will be. So far, so good? Okay. For problems 6 through 9 now, look what we're varying. We're varying inversely. So that's going to be the y equals k over x. Okay? So now when I look at number 6, y equals 4 when x equals 3. I'm going to come back over here and I'm going to do number 6. We're skipping 5 because we did 5 and the paper, right? We needed the graph. So for number 6, y equals k over x. Y is 4 when x is 3. How do I get rid of that 3 that's in the denominator? Multiply by it. So what is k? K equals 12. No.
Really?
Did you say y equals 12x?
Yeah.
No. It's inversely, so y equals 12 over x. Inversely. So k equals 12 and y equals 12 over x. Okay. Number 7, y equals 24 when x equals 1/3. Y equals kx. Y is 24 when x is 1/3.
Did you simplify that to just under 3?
No, because we're not multiplying by 1/3. We're dividing by 1/3. If the 1/3 was up here, then I would put it underneath. But it's already, the whole thing is underneath. You can't put just the 3. You can't move the 1 to the top.
So we won't have that here.
Multiply by, no, you always multiply by what's in the denominator. What's in the denominator? 1/3. So the difference here between, look up here, when I did the k times 1/4, and so I was able to move the 4 to the bottom, the difference is I'm multiplying k by that fraction. Here I'm not multiplying k by a fraction, I'm dividing by a fraction. So I have to multiply by that whole fraction. Okay? So that my fractions cancel on the right hand side. What's 1/3 times 24? 1/3 of 24? 8 equals my k value. So then my equation is y equals k over 8. We're solving for k.
Wait, why did you substitute the k to x?
Okay, so
Be-
on
Oh, you're right. Sorry. You're right. We solve for k. That means the 8 goes in for k over x. That would have been hard to graph later if we didn't have an x anymore. All right, so k equals 8. And y equals k over x. Number 9, or 8, y equals 9 when x equals 5. So for number 8, y equals k over x. Y is 9, and x is 5. What do I do? Multiply both sides by 5. Which means 5 times 9? 45.
Y equals 45 over x.
45 equals k. So yes, y equals 45 over x. Make sure you're answering the question that I ask. I know sometimes you want to get ahead, but answer the question that I'm asking. All right, so k is 45. Oops, they didn't leave me enough room to write my equation if it's a fraction. 45 over x is my fraction. Number 9. All right, number 9, y equals 15 when x equals 4. Y equals k over x. Y is 15 when x is 4. How do I solve?
You times it by 4.
Multiply both sides by 4. 4 times 15? K equals 60. So my equation is y equals, yeah, 60 over K. Or 60 over X.
Once to graph it,
Uh-huh.
big numbers stick out.
K equals 60. So y equals 60 over X. All right, it does want me to graph them. So what I've done is I already, because I do all this to make sure I know where we're headed. I've already made tables because remember we're supposed to do this without a calculator. So I already made tables for each one of these. So I have y equals 12 over X. So basically you're just taking 12 and dividing it by X, right? So 12 divided by 6 is -2. 12 divided by 5 is that ugly fraction. 12 divided by 4 is 3. So I already made the table. So we're going to graph the points that are nice, pretty points. I'm not going to make us graph -12 That's silly. Okay? So -6, -2. We're first doing, this is number 12 over X, number 6. So I'm going to do it in blue so it matches the colors. All right, so -6, -2. -6, 1, 2, 3, 4, 5, 6, -2. -4, -3, because right, we're dividing by 12. So 12, or we're dividing into 12. So -4, and then when you divide 12 by -4, you get -3. And then -3, if I divide 12 by -3, I get -4. And then -2, if I divide 12 by 2, I get -6. 3, 4, 5, 6. So notice it's not a straight line, it's like curving, right? -1 would be -12, which would fall off my graph by like 2 things because it goes to 10. You could kind of stick it under there if you wanted to, though. At 0, it's undefined, right? If I divide by 0, my calculator gets mad at me. So that means there's what we call an asymptote right here at 0. Okay? It's fun to say the word asymptote, I know. It means you approach it and you never actually equal it. Okay? At 1, if I do 12 divided by 1, 12 over 1 is 12. So again, that would kind of fall off my graph 2 above. 2, 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is 3. 12 divided by 5 is ugly. 12 divided by 6 is 2. And then the next one would be 12 divided by 12, which would be 1, but you fall off the graph to try to get there. So what this graph ends up looking like is it's 2 pieces that are curved. You have one that looks like this. And the other one looks like this. And this is my y equals 12 over x. All right, for 8 over x, I looked at my numbers between 1 and 10 to divide 8, right? 8 can be divided by itself, it can be divided by 4, it can be divided by 2, it can be divided by 1. I know when I try to divide by 0, it's always going to be undefined. 8 divides by 1, 8 divides by 2, 8 divides by 4, 8 divides by 1. So that's how I figured out which numbers to pick. Okay? So, 8 divided by -8 is -1. So, -8, 5, 6, 7, 8, we're at -1. At -4, 8 divided by -4 is -2. 8 divided by 4 is 2. -2, 8 divided by 2 is 4, so go down 4. -1, 8 divided by 1 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. At 0, you're undefined. So this graph's gonna, well, this side of this graph is gonna curve also. Looks something like, oh, I'll get it. And then we'll do the same thing for the positive numbers, right? 8 divided by 1 is 8. Well, if I can get this to come back up. So 8 divided by 1 is 8. 8 divided by 2 is 4. 8 divided by 3, 8 divided by 4. I'm not going to do 3. 8 over 4 is 2. 5, 6, 7. 8 divided by 8 is 1. I just plotted the 1 to divide evenly by 8. So I didn't have to worry about plotting fractions. So here is going to be my orange graph is y equals 8 over x. The next one, 45 over x. So I want things that divide by 45. So 45 divides by 1, but it doesn't fit on my graph, right? 45 divides by 5, right? What's 45 divided by 5? 9. So if I go 1, 2, 3, 4, 5, then I will be at 45 divided by 5 is 9. 1, 2, 3, 4, 6, 7, 8, 9. 45 is not divisible by 6 or 7 or 8, but it is divided by 9. What's 45 divided by 9? 5. 1, 2, 3, 4, 5. There's no other points that will fit on this graph, but I do know the shape is not going to be, even though I only have 2 points, I know my shape is not going to be linear. It's still going to curve just like before. So it's going to look something like that. Y equals 45 over x. And now I still need this side. The ones we did were 5, 9, and 9, 5, because those are the only things that make 45. So it's going to be the same thing over here, 5, 9, and 9, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then at 9, 1, 2, 3, 4, 5. And we know it's going to curve. All right, one left, 60 over x. Do you think it's going to be closer in, or do you think it's going to be the furthest out? Yes, if you look, we're going 8, 12, 45. The bigger the number, the further out we end up. Okay? On my graph, 60 divided by 1, it does divide by 1, but 60 does not fit on my graph. Divided by 2, but 30 does not fit on my graph. 60 divides by 3, but 20 doesn't fit on my graph. 60 divides by 4, but 15 doesn't fit on my graph. 60 divides by 5, you could get 12 on the graph. 7, 8, 9, 10, 11, 12 would be about here. So 6 and 12, I'm going to put it down here in the negatives too. Well, if I remember the number 6. 1, 2, 3, 4, 5, 6, and 12, so 2 below the graph. Okay.
It's 5.
Oh, it's 5 and 12. I move everything over. All right, and then, oh, right, because 6 goes in to 60 10 times, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I was on 5. I had counted over to 5. I had put my dot in the right space. I just said the wrong number, I guess. 6 and 10. 6 and 10. 7 doesn't go into 60. 8 doesn't go into 60. 9, 10. 10 and 6.
10 and 6.
And then you could put your 12 and 5. So 10 and 6. And 12 and 5. So we were correct when we theorized that it would be further out than the green. Y equals 60 over x. Okay, so that's what those lovely graphs are going to look like. Questions on solving indirect and direct, just basic given to you information. Okay. For problems 11 and 12, write the variation function that's described in the given statement. So number 11, y varies inversely with the square of x. So y varies inversely. So is that going to be k over something or k times something? K over. And what is k going to go over? Yeah, the square of x. So x squared. Number 12, y is directly proportional to the cube of x. What does that look like? Yes, kx cubed. Easy peasy. So now, we're going to do a couple of, we may not get very many of these done, but we're going to do a couple of them. At least one or hopefully two. Some application problems. I'm going to get a new sheet of paper. It's known that the distance of a spring is stretched by hanging a mass varies directly with the mass. So the distance varies directly with the mass. So for number 13, the distance varies directly, so I'm going to multiply, with the mass. Does that make sense? Okay. So then as I keep reading, it says, this is known as Hooke's law. If the distance a mass stretches a spring is 0.2 meters, so my distance is 0.2 meters. When the mass is 4, what is the proportionality constant? What do I do to solve for k? Divide. So 0.2 divided by 4. Any ideas? 0.2 divided by 4. 0.5?
No, it's not. It's 0.05.
0.05. Very good. There's my constant of proportionality. Now it says, what distance would this spring be stretched by a 7 kilogram mass? Okay, so now I want to know what distance when I have a constant of 0.05 and a mass that's 7 kilograms. Yeah, so now you just solved that, right? I do 0.05 times 7. Well, 7 times 5 is 35. Move your decimal over 2. So my distance is 0.35. And my units here are meters. So that's my distance. That's my constant of proportionality. 0.35 meters. So a little more than a third of a meter. A little more than 33 centimeters. Okay? A person's weight on Mars varies directly with that of their weight on Earth, E. So we're using W for weight on Mars. I would probably use an M, but they're using W. W for weight on Mars varies directly with weight on Earth, E. So the weight on Mars, W, varies directly with the weight on Earth, E. Everybody good? Okay. A person who weighs 140 pounds on Earth weighs 56 pounds on Mars. So on Mars, they're 56 pounds. On Earth, they're 140 pounds. What do I do to solve for K? Divide by 140. What is it? 0.4? Did you do that in your head? Now you do know you do not get a calculator when you take the test. And this will be the type of question you'll be asked. So probably you'll end up reducing your fraction and you won't get a 0.4. You'll get a 4 over 10, which is 2/5. Right? Every 0.2 is a fifth. So if you have 0.4, that's 0.2 plus 0.2. So it's 2/5. Okay? So my constant proportionality, if we didn't use a calculator, we probably would have gotten 2/5, unless you did long division. And then it says also, it says how much would a person who weighs 185 on Earth weigh on Mars? So on Earth, if I'm using 2/5 as my constant proportionality and we weigh 185 pounds, what would my weight be? Okay, so I need to multiply this by 2 and divide it by 5. It doesn't matter what order you do it in. I would probably do the 185 divided by 5 first because I know it goes in evenly. So that's going to be a 3. That's going to be 15, 16, 17, 18, 37. And then 2 times 37 is 74. And my units were pounds, right? Pounds. So on Mars, if I'm 185 pounds here on Earth, on Mars I'll be 107, or I'll be 74 pounds. Alright, number 15, I don't know if we'll get this one in. This one is also directly, we probably should have done number 16. Let's look at 16. I'm going to skip 15. The weight of an object on Earth varies inversely as the square of its distance d. So, number 16, I'm skipping 15. The weight of an object on Earth, I'm going to use W. Inversely, so K over the square of the distance d. So, the weight varies inversely to the square of the distance d. I'm just going to do the equation there, and I'm going to let you finish out the exercises. So finish out those exercises. I am going to give you the assignment so that you can start working on it because we are going to start 8.2 tomorrow. Okay? We are going to start 8.2 tomorrow.